Welcome back, ladies and gentlemen. So, pretty exciting. We are starting our last unit. It's the last test. Hopefully, we're ready to buckle down and really work hard through this last part of the year. Here is your daily warm-up. So, find the area of each polygon or circle. One trapezoid base is 12 feet and 18 feet, and the height is 3 feet. 2, a circle with a diameter of 8.2 inches. 3, a regular hexagon with a side length 4 centimeters. So, as you can no doubt guess, I am trying to record this in the morning before school starts. I think we might have a lot of those interruptions. Okay, give these a try and try to see how you do. I'd recommend you practice giving your answer in exact form. All right, let's see how you did. Find the area of each polygon or circle. So here's a trapezoid. Here's the formula, and it's just plug away. And as my calculus teacher said in high school, plug and chug. So chug away, you just plug it in. And there you go, 45 square feet. Circle, diameter 8.2 inches, which obviously means the radius is 4.1. Here's our formula. Plug away. Here's your answer. Remember, we don't like decimals with our pi, so let's turn that into a fraction. This is the hundredths place, so we're going to put it over 100. So much better looking. Okay, regular hexagon, side length 14 centimeters. Their formula. Okay, so if you're 14 centimeter side length, think about that apothem. Hopefully you found that to be 7 root 3. The perimeter, 84. And let's just simplify that. There's your exact answer. All right, rolling right along. Today, we are starting volumes of prisms and cylinders. So exciting. Here's your basic formula. The capital B times H, capital B is the area of the base. Really important to pay attention to that. Times the height of the prism. Okay, similarly, the volume of a cylinder, we've got the area of the base times the height. But in this case, the area of the base is a circle, so we've got pi r squared. So, take a moment, find the volume of the right trapezoidal prism. If you need to, feel free to pause the video and keep working. Okay, there's our basic formula. Now, as you go through these problems, you have to think, okay, what's the shape of the base? They're telling us it's a right trapezoidal prism. So, it's a trapezoid. That formula is 1/2 the height of the trapezoid times base 1 plus base 2 of that trapezoid. The height of the prism, 6. Again, just if you can get those and plug those in. So all of this part represents that capital B. That's the area of the base. 6 is the height. And then we get 288 cubic centimeters. Okay, we're talking about volume. So we have just switched from square to cubed. All right, next up, find the volume of the right cylinder. And if you need to, go ahead, pause the video, take a moment to try this out. Area of the base times the height. Area of the base is pi r squared. Height is 5. Standard answer there. Keep it exact, 320 pi cubic feet. All right, let's work backwards. The volume of a cube is 135 cubic inches. Find the value of x. All right, take a moment. I would recommend you maybe draw this out in order to try to solve it. And feel free to pause the video if you'd like. Oh, great cube. It's a die. So here's our sides. X, x, x. We want to find the value of x. Well, the side cubed will give us the volume. Okay, because it's a cube, we can do that. So 135 equals x cubed. In order to solve for x, we're going to take the cubic root. So the cubed root of 135. Should be able to find that on your calculator, or there's a couple different ways to enter it. Feel free to ask a friend, ask us if you have questions, let us know. But it's approximately 5.13 inches. Okay. Sorry about that. So this is demonstrating how we could get an exact answer on this. So this is the approximate answer. When we take the cubic root, we have to find, are there any perfect cubes that go into 135? Yes, indeed. 27 is 3 times 3 times 3. So we can break that down into the cubed root of 5 times 3. Again, I think it's a little tricky to see this. If you have questions, please let us know. Okay, great news. Here is Cavalieri's principle that talks about the fact that if all of these have the same height and that essentially cross-sectional area is the same on all three, then all of them will have the same volume. Doesn't matter if they are right or oblique. If they have big B, that cross-sectional base is the same and the height's the same, they'll all have the same volume. So exciting. So all that means is that when we do a problem like this, if they're giving us the height, we can use the exact same formula. There you have it. So with this problem, we can just do it exactly the same as we would try another one. Much better answer, this exact answer, but rounded, here's what it would be. Don't forget your cubic centimeter label. Okay, so give this one a try then. Since it's an oblique prism, give this a try. And again, feel free to pause the video, try it on your own. Okay, area of the base times the height. We can use that 8 centimeters as the height. The area of the base is just 6 times 12. We'll multiply those together and we get 576 cubic inches. Ooh, great problem. Okay, so a cistern is a large tank used to collect rainwater. It is made of concrete that is 3 inches thick and is open at the top. Find the volume of concrete needed to make the sides and bottom of the cistern. This is a great problem. So I want you to think, try it out, do your best, pause the video, give it a try, and then let's check it. All right, hopefully you got to the point where you figured out, okay, if I take the volume of the outside one and I subtract the volume of the inside, that should give me that middle volume. So big R stands for the radius of the whole thing. Little r stands for the radius of just the inside part. We can see that the big radius is 18. Since this part is 3, the inside radius is 18 minus 3, which just gives us that 15. We also need to take into account that the whole height is 20, but the inside height is only going to be 17 because there is also 3 inches on the bottom. So it's just another problem. Once we get all those numbers and plug them in, we can then chug away on our calculator. 6,480 pi minus 3,825 pi. Those we can combine to get a grand total of 2,655 pi cubic inches. All right, hope you enjoyed learning about the volume of prisms and cylinders. Sorry for the couple of lapses in my recording. I was interrupted a couple times. Here's your homework, and good luck. Let us know if you have questions.